Coming to you live from the heart of the TARDIS, pre-calculus math 11. Dots. Logic! Today, section 4.2, solving quadratic equations by factoring. Well, last year in Math 10, you learned this really awesome party trick called factoring quadratic equations. And unfortunately, you were never really given a context within which to use this skill other than amazing your friends at parties. Well, this year, we finally get to put those skills to use. Now, let's play a little game here. If I told you that I was thinking of two numbers, let's call them A and B, such that A times B was equal to 0, what would you say? You would rightly say that either A or B must be equal to 0, or possibly both of them. And you'd be absolutely right. Now, what if instead of A and B, the two things that we were multiplying were binomials? What if we had x plus 5 times 2x minus 3 equal to 0? This would mean that either x plus 5 is equal to 0, or that 2x minus 3 is equal to 0. And I think both of these are pretty easy equations for us to solve. This would give us either x is equal to negative 5 or x is equal to 3 over 2. And being able to solve a quadratic equation like this through factoring is actually one of the main reasons that we learned how to factor different types of quadratics last year. Let's take another example. Solve 3x squared minus 8x equals negative 4. Well, whoever wrote this question is kind of a jerk, but it highlights an important part of solving quadratic equations. Always put everything on one side of the equation so that it's all equal to 0 and then factor. And while I agree that you could probably take a common factor of x on the left side, I don't think that helps. Having two factors that multiply to give me negative 4 isn't useful, whereas having two factors that multiply to give me 0 makes it obvious that one or both of the factors must equal 0. And this is what we call the zero product property. If A times B is equal to 0, then either A or B must equal 0. There is no negative 4 product property or any other such thing, only the zero product property. So the first thing to do here, let's get everything onto the left-hand side and set this equation equal to 0. Now remember how we factor this. 3x squared obviously is coming from x times 3x. 4 could be coming from 1 times 4 or 2 times 2. I have to play around with the numbers a little bit to see, but I think it's fairly obvious that it's minus 2 and minus 2. Double checking, the outer two terms multiply to give negative 2x. The inner two terms multiply to give negative 6x. That gives a sum of negative 8x. That's exactly what I want. So what are the solutions? Well, obviously x is equal to 2, or x is equal to 2 over 3. And if you check these back in the original equation, you'll see that this works. And here's another one that we can try. X squared equals 12x minus 36. Again, start by putting everything equal to 0. I could move everything to the left-hand side, or I could bring it all over to the right-hand side. It doesn't really matter. Let's go to the right. Now, I don't really like having this start off with a negative, so what I'm going to do is multiply everything, both sides of the equation, by a factor of negative 1. That just changes the signs for me. And I think if you look at it carefully, had I moved these terms over to the left in the first place, this is what I would have had on the left-hand side anyway. Well, now to factor. X squared, obviously coming from x times x, 36. Hey, 36 is twice as much as half of 12. Oh, we've got a perfect square here in these two factors. You could also write this as x minus 6 squared. This means that the solution to this equation is x is equal to 6, and it actually happens from both of these brackets. So we've got two solutions here that just happen to be equal to each other. If you think about this in terms of the graph of this parabola, it would be a parabola that's opening upwards, and over here at x is equal to 6, it's just touching down before it turns around and goes back up. This is the case that I was explaining in class about how there's two x-intercepts here that just happen to be equal to each other. An 8 by 10 photo is framed inside a border of uniform width. By uniform width, I mean it's the same width on all four sides. The area of the border is half as much as the area of the photo. There's a lot of different questions we could be asked here. How wide is the border? What are the outer dimensions of the border? Let's first of all get the picture, and we'll get the border set up around it. Now we know that the picture is 8 by 10. So we've got 8 and 10 as the dimensions here. And we've got a uniform width on all sides, meaning this and this and this and this are all the same width. I'm going to call that width W. I don't just like to throw out a variable. I like to always have a good definition for what does that variable represent. Now the question doesn't specifically say, but I'm assuming that the unit of measurement is inches, but whatever it happens to be, we can just use the same units. Now let's set up an equation talking about the area of the whole thing, because area is something that we've got information about here. The area of the border is half as much as the area of the photo. Obviously the area of the photo is 80 square units, whatever they are, and so the area of the whole thing is going to have to be 80 plus half of that, 120 square units. And we get that 120 by multiplying this width by this length for the whole thing. Well, if it was 10 units from here to here, and we've added on a W and another W, that would mean that the total length of this is 10 plus 2W. And the total width, again, was 8 across here, and we've added on a W here and a W here, so that's going to be 8 plus 2W. And we've got the startings now, the makings of a nice little quadratic equation. I'm going to expand this, simplify it, and put everything onto one side of the equation. And now we're ready to factor this. Well, I think the best thing to start with is to recognize that all three of these terms have a common factor of 4. And I could just factor it out like we did last year, saying 4 times W squared plus 9W minus 10. But I could also consider, hey, if I divide everything in this equation by 4, well, 0 divided by 4 is still 0. I actually don't even need that 4. I can just get rid of it entirely. Now let's factor. W. Things that multiply to give me 10 are either 1 times 10 or 2 times 5. Considering we have 9W in the middle, I'm going to work with plus 10 and minus 1, giving me W is equal to negative 10 or W is equal to 1. Well, only one of these answers makes any sense in the real world. Obviously, the width of the border must be a number that's greater than or equal to 0. Negative 10, I'm going to have to reject and stick with 1 as the actual width of the border. So we can answer the question, how wide is the border? It is 1 unit in width. And what are the outer dimensions of the border? That would be all the way across here. Well, we said 10 plus 2w, so the outer dimensions are 10 by 12. And now it's time once again for
Two for You.
Question number 1, solve the following quadratic equations by factoring. Remember, put everything on one side. And question number 2, 3 sticks have lengths of 22, 43, and 46. We cut the same amount off of each stick, and the remaining lengths form a right triangle. Fascinating! Well, that's all for today. Remember, until next time, keep your pencils sharp, and I'll see you in class.